Hello everyone, my friends. Today we are going to solve the problem of UPSC 2005 from topic Jacobians. Here in the question, if u is equal to x plus y plus z and uv is equal to y plus z and uvw is equal to z, then find the value of del of x comma y comma z upon del of u comma v comma w. Let's solve the problem. Given u is equal to x plus y plus z, let this equation 1, and uv is equal to y plus of z, let this equation 2, and uv w is equal to z, let this equation 3, and we have to find that is del of x comma y comma z upon del of u comma v comma w. We have to find. First, putting the value of y plus z in equation 1, that is u is equal to x plus, in place of y plus z we have to put uv plus of uv, and from here we can also write that is x is equal to u minus of uv, and further we have to put the value of z in equation 2, putting the value of z in equation 2, that is equation 2 becomes uv is equal to y plus of z. Z in place of z we have to put the value of z, that is u v w, then the equation becomes y is equal to uv minus of u v w. From here we get x is equal to u minus of uv, and y is equal to uv minus of uvw, and z is equal to uvw. Further we have to solve del of x comma y comma z upon del of u comma v comma w. It is given by determinant of del x upon del u and del y upon del u and del z upon del u, and del x upon del v, del y upon del v, and del z upon del v. This is del x upon del w and del x upon del y upon del w and del z upon del w. We have to find the value of del x upon del u, del x upon del v, and del x upon del w, and del y upon del u, del y upon del v, and del y upon del w, and del z upon del u, del z upon del v, and del z upon del w. And we have to put in the determinant to further solve the determinant. From here, x is equal to u minus uv. We can find that is del x upon del u, del x upon del u. Differentiating x is equal to u minus uw with respect to u, that is 1 minus of v. Further we have to find del x upon del v, del x upon del v. Again the value of x differentiating partially with respect to v, that is here u is constant 0 minus of u. Further we have to find del x upon del w, del x upon del w. Again the value of x differentiating partially with respect to w. Here is the coefficient of w is not present, so it is 0. Further we have to find del y upon del u, del y upon del u. The value of y partially differentiating with respect to u, here uv differentiating partially with respect to u, that is v, and minus of uvw differentiating partially with respect to u, that is minus of vw. Further we have to find del y upon del v. Del y upon del v. The value of y differentiating partially with respect to v, that is uv differentiating partially with respect to v, is u minus of uvw differentiating partially with respect to v, taking u and w is a constant, that is minus of uw. Del x. Further we have to find del y upon del w, and del y upon del w, here is the value of y differentiating partially with respect to w, that is minus of uvw differentiating partially with respect to w, that is minus of uv. For third we have to find del z upon del u. The value of z differentiating partially with respect to u, taking vw as a constant, differentiating u with respect to u is 1, that is vw, and del z upon del v. The value of z differentiating partially with respect to v, that is uw, and again we have to find del z upon del w. The value of z differentiating partially with respect to w, that is uv. Putting the value of del x upon del u, del x upon del v, del x upon del w in the above determinant, that is del x upon del u is 1 minus of v, and del x upon del v is minus of u, and del x upon del w is 0, and del y upon del u is del y upon, this is y, del y upon del u is v minus vw, and del y upon del v is u minus uw, and del y upon del w is minus of uv, and further del z upon del u is given by vw, and del z upon del v is given by uw, and del z upon del w is given by uv. Further we have to solve the determinant. Del of x comma y comma z upon del of u comma v comma w. Further we have to solve, this is C1, C2 and C3. This is column C1, C2 and C3, and this is row R1, R2 and R3. We have to take a row operation, that is del of x comma y comma z upon del of u comma v comma w. On using row operation, that is R2 replacing R2 plus R3. This is R3. First we have to start the operation. R2 replacing R2 plus R3, that is, one second. We have to write here, that is del of x comma y comma z upon del of u comma v comma w, and we have to go through the row operation. R2 replacing R2 plus R3, that is 1 minus of v and minus of u and 0, because the R1 is not change, and R2 in place of R2 plus R1, that is minus of V minus of VW plus of VW, that is cancel out, then the remaining is V, and from here it is U minus of UW plus of UW, UW minus of UW and plus of UW is cancel out, then the remaining is U, and from here R2 plus R3, U minus of UV plus of UV is cancel out, it is 0, and remaining is VW and UW and UV. Further we have to take operation, that is R1 replacing R1 plus R2 plus R3. Then the determinant becomes this is R1, this is R1, R2 and R3. We have to replace R2 with R1 plus R2 plus R3, that is 1 minus of V plus V, that is 1, and minus of UW. Once again, that is this is R1, R2 and R3. That is 1 minus 1 plus of VW, and for this minus R1 plus R2 plus R3, that is R1 plus R2, that is U2 is cancel out, then the remaining is UW, and this is UV, R1 plus R2 plus R3, that is this is UV, and once again here is operation is R2 replacing R1, R2 plus R3, then minus of UV and plus of UV is cancel out, then the 0, and U minus UW plus of UW is remaining U, and minus of V minus of VW cancel out, remaining is V. Further we have to solve once again UW. We have to take operation in R1 replacing R1 plus R2, that is 1 minus of V plus V, 1 minus of V plus V is 1, and minus of U plus U is 0, and 0 plus 0 is 0, and further that is V, U, 0, and VW and UW and UV. Further we have to expand the determinant with respect to 1, that is this and this is cancelled out, and the remaining is then the remaining indeterminate of U and 0 and UW and VW. We have to solve on equation, that is UVW and minus of, once again, taking operation, that is 1 minus of V plus V is 1, and this is 0 and 0, this is also 0, this is V, U0 and U0 and UW and VW. We have to UVW minus of UVW minus of 0. This is the required solution x comma y comma z upon del of u comma v comma w. We check the answer, that is UVW. We can also solve. We can also open with respect to UV, that is this and this is cancelled out. Then the remaining portion is del of x comma y comma z upon del of u comma v comma w is equal to UV bracket UV and determinant remaining is V U and U VW and UW. Further we have to expand, that is UV and UVW and minus of UVW. VU VW UW. Expanding for UV, then this and this is neglect, then the remaining is 1 minus of V, 1 minus of V and minus of U, and here is V and U. On expanding our determinant, that is del of x comma y comma z upon del of u comma v comma w, that is UV is already present, and cross multiplication with, that is U minus of UV, and here is minus is already present, and when cross multiplication with this part minus is taking, that is plus of UV, and minus of UV and plus of UV is cancelled out, then the remaining answer is U square V. This is the required solution of the given problem. Thank you class and thank you for watching.